So today we're going to look at vertical circles, and this is number 4 in OneNote. Vertical circles are different than the horizontal circles that we've been moving in because they have the extra component of weight, so FG. So let's look at a for example here on this loop ride. Someone riding this roller coaster would ride upside down, and if they were riding this upside down, that means their weight, Fg, is going down, and also the normal force from the track. I know it's hard to see on this picture, so I have it drawn over here. So picture the track right here. The normal force from the track pushes inward, and so does the Fg. So if we write the equation, Fc equals Fn plus Fg. And that plus is very important. They're both adding together to give it the centripetal force it needs to stay in the loop. If we're on the bottom of this track, so somewhere down here, we have the normal force facing up, and our weight, of course, still acts down. I have it drawn over here a little bit better. The track is right here, and so the normal force acts up, Fg acts down, and remember the center is always the positive one, so Fn minus Fg. So the normal force is going to be greater at the bottom. And if you've ever ridden a roller coaster, you've experienced this. You feel pressed into your seat at the bottom of the roller coaster because Fn has to be greater than Fg in order to keep you in the circle. Because remember, this is unbalanced. So, a couple of things you need to know. Fg is going to be constant, and that should make sense because we're here on Earth. Ft is not constant, so if you're twirling something in a vertical circle, it's going to be greater at the bottom, and it's going to be less at the top. And you know this if you've ever tried to twirl a whistle, and the whistle just didn't quite make that circle. So the tension wasn't enough at the top to keep it in the circle. Up here, we would say that Fc is equal to Fg plus Ft1. Down here, we would say that Fc is equal to Ft2 minus Fg, where Fg is the same, so just what we saw in the previous slide. Now, a little bit different is if you have a Ferris wheel. So if a Ferris wheel, your normal is always up and your weight is always down, and it kind of alternates because this is the center of the circle. At one point, it's the normal force giving you the centripetal force. At the top, it's your weight giving you the centripetal force. So here, you would say Fc is equal to Fg minus Fn. At the bottom, you say Fc is equal to Fn minus Fg. And let's just recall that whatever's pointed to the center of the circle is the positive one. So normal on the bottom, Fg on the top, and the other things are taking away from it. And just for comparison, let's write this one out. Fg plus Ft, and Fc equals Ft minus Fg.